Hi, this is Mrs. Yenny, and this is video number 2 for What Do You Expect? And in this video, we're going to be really focusing on these two learning goals, learning goal 1 and 2, which will talk about determining the probability of independent and dependent events. So let's get started. We're going to be talking about area models right off the bat here, because that's really the focus of Investigation 2. So Investigation 2 is about analyzing situations using area models. So first of all, let's talk about what an area model is. An area model is a diagram in which fractions of the area correspond to probabilities in a situation. So to give you an example of what that means, I have this bucket problem, and I'm going to give you 2 total examples today. And in both cases, I'd like you to follow along with me, taking notes and actually running through the area model just like you would any problem. So this bucket problem has to do with drawing a marble from each bucket, and we want to know the probabilities of various situations or various outcomes occurring. In bucket number 1, we have a red marble and 2 greens. And in bucket number 2, we have a red, a blue, a green, and an orange. And so to start our area model, we start by just drawing a square. And this is the 100% area that we're going to work from. What we're going to do next is split up our area model, like you see here, to represent our first draw from bucket number 1. And since there are 3 marbles in bucket number 1, I split the area model into thirds, and I labeled that red, green, green to represent the 3 colors of marbles in bucket 1. I'm taking it one step further to represent the draw from bucket number 2, and since there are 4 marbles in bucket number 2, I'm now splitting the area model into fourths vertically. As you can see now up here, I'm going to have a total of 12 possible outcomes. And then since I labeled each of these sections, I'm able to actually write in what the outcomes are. So now you can see here, this is a red-green, probability of drawing a blue-green, a green-green, etc. Alright, so once I'm all done, remember from video number 1, we know that finding all the possible outcomes really helps us determine the theoretical probability of any given event. So this is how we're sort of analyzing the probability in this situation. So I just came up with a couple of examples. The probability of drawing a red-green, of ending up after the 2 draws with a red marble and a green marble in your hand. We can see that that can happen 3 different ways here. So there are 3 outcomes out of 12 that would result in that, which is also known as 1/4 or 25%. The probability of drawing a red out of each bucket, so a total of 2 reds, is just 1. There's just 1 chance out of 12 that that can happen, which is about 8%. So that's the first example of how to use an area model to analyze situations. Now we're going to look at a separate area model example. And this one has to do with probabilities of dependent events. So it's a little more complicated, but it's going to look fairly similar. So we're going to start with this little story here, because I like to do this little story that goes with this maze. This is a maze, what you see here, and these are pathways, basically, pathways through this maze that lead to either room A or room B. So the story goes like this. This is a princess, and this is her peasant lover. And her father, the king, found out that she was in love with this peasant lover, and he was furious. So he ordered the peasant to be thrown into a room full of tigers. He was basically going to walk through this elaborate maze and end up in a room full of tigers. So the princess, being the wise, smart girl that she is, she pleaded with her father and asked if she could wait in one of the 2 rooms. That she understood he wanted tigers in one room, but she wanted to wait in one room, and she wanted to be able to determine which room she would wait in. Well, her father, the king, looked at the maze and he said, "Sure, that's fine. It's a 50-50 chance." Her father simply looked here and counted 1, 2, 3 paths ending up in room B, 1, 2, 3 paths ending up in room A, so it shouldn't matter. So he agreed. He allowed his daughter to choose which room she would wait in. So luckily, she was very attentive in math class, and she analyzed the probability of this situation using an area model, and she was able to determine the best room to wait in. In other words, the room that gave her the best chance of her peasant lover finding her. If, of course, he's making these choices at each of the intersections along the path randomly. So let me show you what she did to calculate that probability. She started with an area model like we did before, just a square, but she starts by splitting that area model into thirds to represent the original path here, taking this separating right here into thirds. So you could think of this top path as path 1, the second path as path 2, and the bottom path as path 3, if you'd like, and that's what the 1, 2, and 3 represent. But then what happens, you'll notice that path 1 splits into 2 right here. So you'll notice that I took path 1 and I split it into half. And then I notice that one of those 2 goes to room B, and one of those goes to room A, so I've labeled them accordingly. So if you look back up here at the maze, you can see that path 2 goes directly to A. Path 3 does something pretty interesting. First, it splits in half, that you can see here, and one of those goes directly to B, so that's why I've labeled it that way. But the other takes off this direction and then splits, and one of those 2 goes to A and the other goes to B. So to analyze this probability back to what an area model is, we're going to look at the fractional pieces of our area model and apply that to our probabilities. So to figure out, in other words, what is the probability of ending up in room A, then we're going to have to add up our fractional pieces that A takes up of the whole. So in other words, if we look at this section right here, we can see that A takes up 1/6 of the whole. Now you might be thinking, no, Mrs. Yenny, that A takes up 1/2. Well, it takes up 1/2 of that third, and 1/2 of a third, of course, is 1/6. And we're looking at the probability of the whole. So this A takes up 1/6 of the whole. This A takes up, of course, 1/3 of the whole. And this little A here takes up 1/12 of the whole. So what we're going to do is we're going to add up those 3 A's, those 3 A sections. So we're going to add up 1/6 and 1/3 and 1/12. And of course, to do that, we have to find a common denominator. And our common denominator we're going to use is 24. So 1/6 becomes 4/24, 1/3 becomes 8/24, and 1/12 becomes 2/24. So when we add that up, we get 14/24, or about 58%. So there's a 58% chance that the peasant lover will end up in room A. So knowing that this whole area model represents 100%, can't I just take 100% minus 58% and end up with the probability of ending up in room B? Yes. So that's what I did here. I took 100 minus 50, oops, that should say 58%, my error, and you should then be left with 42%. So of course the princess knew that, and she did wait in room A because there was a greater chance that her peasant lover was to end up in that room. And to find out what happened to the princess, her peasant lover, the tigers, and the king, we will have to wait for video number 3. Thanks for listening.